So I'm guessing it's live now. So let's have a check if you can hear me. I'm just going to check on my laptop that it's live. And once I see that everything is actually live, then I'll start whatever I am doing. And it looks pretty good at the moment. Check the sound. Have we got sound? Check the sound. Okay, looks pretty good. So looks like we have sounds, and I can see everything here, so that's good. Right, okay, so welcome to this Hangout. Right, basically my name's David Thorne. I'm a full-time Swift developer. I create iOS apps. If you haven't already seen my other videos, in this video, or this kind of evening, I'm going to be going through TypeScript, essentially JavaScript, but with lots of types on it, something which Microsoft has invented. And I'm really doing this for absolute beginners. All right, so I'm on the understanding that you know basically nothing about programming JavaScript. Okay, so you've kind of got a little bit of knowledge about programming, but yeah. So and if you're watching in the live chat, then then ask me a question, or if I'm going too fast, then tell me to slow down. But just remember, there's a little bit of a time lag between my voice and also, yeah, me seeing the message and stuff like that, and stopping talking. And you, all right? But let's just going to give it another 1 minute, and then I'm going to start. So I see that there's possibly another person watching. If you just want to write a comment in there just to see that you're actually everything's working, and just to help me out, would be really, really cool to tell me that you can actually hear me properly, the sound is correct, and everything is all okay. Anyone want to do it for me? Okay, so anyway, this is pretty cool, because before when I made videos, I'd sit there and I would then do a screencast, and I'd have to worry about whether everything worked out all right. But this way I can actually have interaction with people to do stuff. So anyway, you don't know anything about TypeScript. What is TypeScript? Well, just to give you a brief background, JavaScript was created a long time ago, and it has lots and lots of problems with the different browsers and so on, but it's basically everywhere now. And what Microsoft did is they created TypeScript. So they basically made a scripting language, which what JavaScript is, and it doesn't have types. So we'll get into what types are later, but essentially what it does is it makes your code a lot stronger. Okay, so there's less bugs and less errors in it. Now there still can be errors in it, but if you use the types correctly, then you can really restrict having or stop these errors from going on. Okay, now if you go to typescriptlang.org, then this is what TypeScript, where the TypeScript documentation is. But first, I just want to go over a couple of things here. Is that if you look in the description, you'll see that, whoops, 1 second. You'll see that I've provided a couple of links, okay? And one is where all of the code will be, okay? And I will be pushing this code every so many minutes or something. Every so many minutes, so everyone's got the code live, what I'm actually coding with. So you don't actually need to follow along, you just need to keep pulling the repository all the time. If you don't know how to do this, then I'll go through shortly and show you how to do this as well, all right? But Okay, the sites is also, we're going to be working on it here local, but if you go to the actual site, you'll see it's youtube-typescript-101-davidthorn.netlify.com, and it's live there. So once I've pushed it to this, it will then be live there as well. So you can actually see interactively everything that I'm doing and work directly along with me. And if you want to contribute to it, then go onto GitHub, and then you can contribute to it as well and start pushing things, and then I can pull your stuff. I don't intend for this to be a short video, all right? I'm going to keep sitting here and just doing this and going through it. It's a Friday evening, and I don't have any plans to go out, so what better than do some YouTube videos, all right, or one video to help beginners, right? Because I've done lots of like advanced things and so on, but when someone writes a comment here or likes something or writes in the chat, then I'll begin, okay? So once I know that people are actually listening and watching, then I will begin. But so I'm kind of guessing that everyone's now been to YouTube, TypeScript 101, David Thorn, Netfly, blah, 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 here, and they've also come to here. So let's get down to the nuts and bolts of it. So we can kind of just scrap this. That's just me creating the header that was there, all right? But we'll get rid of this. Whoops, wrong code key there. Okay, and then we'll put this down as well, and we'll get rid of this here. Oh, what is this thing there? Like that there. That's right. That's better. Okay. So JavaScript. Now, first of all, let's go through what types are, all right? Now, in programming, we've got some primitive types, and these are the real hardcore ancestors of programming, okay? And they go back to the initial days when they started to actually have bits and so on of programming. And these are, okay, so we have integer, okay, we have double, we have floats, we have array, we have null, we have objects. I'm kind of adding all of these, which are for JavaScript, okay? And in here we have undefined, integer, and we also have string. It's not really a primitive type, but they're types, okay? And we've then got angle brackets as well. We've got objects like this, and we've got objects as well. We've got enums. Oh dear. And there's some more, okay? So these are all the types that we're talking about. Now in TypeScript, it's number. There isn't a double, there isn't a float, and you can have any as well. And you can also annotate your code with return types and so on. So if you've done arithmetic at school, you'll know that having two, well, if we just say, if we completely ignore what const is, we'll just say num equals 1, okay? And then we're going to say num2 equals 2. And then we're going to say answer, or we say sum equals, let's move this, sum1 plus, excuse me, so sum equals num plus num1. Now, this is all it is saying is that assign this number, all right, to this variable num. And this here is saying assign the value 2 to the variable num1. Okay, and this here is doing nothing more than saying, hey, what I want you to do is I want to take the value of num and the value of num1 and plus the two together, and then assign that value to then the variable of sum. So now we know that sum has the value of 2 plus 1 in this situation, so it's going to be 3. Okay, so this is then, these are then variables. Now, when I say it's a variable, it means that it can change. Now, we've got it in the original JavaScript, everything was just declared var, which is the short term for variable. Okay, so this would have been written like this, and then this would have been written like this, whoops, and then var sum is equal num plus num1. And we need to just comment this out so it doesn't go red. And that's variable. Variable just means that any type could go into this, and it's these types here. Any of these types could be assigned to num. Just because we're using the word num doesn't mean to say that it's actually a number, right? It can be named anything, and there is also conventions for this, that you can only start it with either a alphabet, a letter in the alphabet, or an underscore. And okay, it doesn't matter whether it's then uppercase or lowercase, but it can only start with either an underscore or a letter. Okay, it can follow, what follows can be numbers as well. All right, so we can have num1 and so on, it doesn't matter, but you can only have alphanumeric characters and the underscore inside a variable name. Okay, and so let's do this. All right, and you can only, in this situation, see, JavaScript wouldn't have given you this problem by defining two var nums and so on. They kind of just ignored it because it ignores nearly everything. Now, what Microsoft has done is create this great IDE called Visual Studio Code, which has a couple of built-in plugins for TypeScript, which is then going to give you it's going to give you errors if the syntax is wrong, or if you haven't. So it's really helpful for you to work with. So okay, so now we have a variable which is then in this case a number. Okay, but we can also then here we can say that this is then num. So this is now essentially a string, right? And let's just skip past that for a second. But it's TypeScript, and what we do is we can define our variables to have a type. And what we do is we use a semicolon, after the variable name to then assign it a type. And here, here we're going to say number. And the IDE is going to scream at us here, or the transpiler, we'll get into later, the transpiler is going to tell you, hey, type string of 1 is not assignable to type number, all right? Well, that's because these double quotes, although there's a number inside of it, a string is a collection, should we call it, of any character whatsoever with inside of double quotes or single quotes. So I could type any character on the keyboard in here, apart from double quotes, and it will be a string. All right, we'll get onto it later on why you can't put double quotes inside of double quotes, but I could write anything in here whatsoever, anything, and it will still be having this problem. But if I change this to string, you'll see now that the problem goes away. All right, because now we're telling the transpiler, it's not a compiler, it's a transpiler, that this variable num has the type string, and everything to the right-hand side of that equal sign, or that assignment operator, is here. It's an assignment operator. I don't want to say an equal sign, right? Because it's not equal in something. It's just the assignment operator. It's saying everything to the right-hand side of me needs to be a string, and if it is, then assign that to the variable of num in this case. Now, if we put this back to number, now we're saying that everything on the right-hand side of it has got to be a number, all right? And now we can then turn around here and say that this has got to be a number as well. And now we can look at, let's just console it out so it doesn't actually moan at us. Now you can see that we've got implicit type casting, or the transpiler has implicitly said what type sum has, all right? In this case, it has, because it has num plus num1, the transpiler has gone, wait a minute, I've got a num on my left-hand side, a num on my right-hand side of the operator here, so that makes it a number. So that must mean that const sum is a number. So we don't have to actually give it a value or have to give it a type, sorry. But in this situation, we're going to give it a number. All right. And now what we've got here is a really, really strong script. So it can tell our code, right, what type is that variable, and also normally before in JavaScript you would just give it a good name so someone knows what type your variable is, all right? But now you can give it any name. As a good programmer, your variables should always reflect what they actually hold, right? They don't have to reflect what the data they hold. They just have to reflect what it is going to be doing, what it's representing, okay? So, because I could put like 39 in here, that's a number, right? But at the moment, it's just a num. But if I say age, then that becomes, now that represents an age, right, of someone. Now, if I say David's age, now it represents, it has a lot more meaning now to this value. So when we use this variable later in our script, in our code, we see David's age, and we know the value in this is a number, and it holds the age of David. Okay, so that's essentially the first step here that we're going through. So what I'm going to do is I'm going to swap back over to here, and then we'll just go through how we do this. Okay, added the first intro, so we just say here introduced const and variables and the number type assignment. Yeah, and then we can push this to master. Why did you not? Oh. I didn't save you, that's why. And do that again. And we'll push it this time. And now once this has been pushed, this will activate a deploy, which is here, is building. And in a second, you'll have the code here, well, you have the code here now, and you see here, the code's now live, and this is now live here. We come to console and we see 41 is outputted. All right, so this is now all completely live for people to use. All right. Okay, have a quick drink. Okay, so now that we're in the console, the magic of JavaScript is that you can actually code it direct in the browser console as well. Now, I'm using Chrome here, so all I've done is then press F12, and that opens up the developer tools, and then I've tapped on console, so I can come straight in here. Now, I can essentially write David's. Actually, it doesn't actually show up for other reasons, but I can say David equals string. This is not going to work in the browser either. right? Because it's TypeScript, and TypeScript is transpiled. So let's go through this a little bit more. All right. So if I take, I'm using something here, which you're just going to have to like skip over. I'm using something here called Webpack, and that's a good tool for doing the building and generating of code. All right, for compatibility for different browsers and so on, because no one should actually write vanilla JavaScript. Now, what's vanilla JavaScript? Vanilla JavaScript is the JavaScript that we wrote, like say 5, 6, 7 years ago. All right, where there was no like huge amounts of frameworks. You just essentially wrote JavaScript, and then you tried your hardest to make sure that it worked over all of the different browsers, be it Internet Explorer, Firefox, Chrome, Netscape, and so on. So that was a real pain, and you tended to spend more time writing JavaScript that was compatible with all browsers, and then it was buggy as well. So they then created the likes of Node and Webpack and so on, where they then got specialists to take your code, and then that transpiled it into code that would be compatible in all browsers, all right, and backwards compatible as well. So Webpack kind of does something like that, all right. I don't really want to get into what Webpack does because I actually don't know 100% how it does it. I just know enough to make it work like this. Now, so at the moment, I've got this main.ts, right? TS files are TypeScript files. Now, a normal JavaScript file has the extension .js, right? So once you've created a .ts file, it needs to be transpiled into vanilla JavaScript. And so in this case, TypeScript has a compiler, and that is then the TS. It's then TSC, which then if we come over to here, it's a bit better. You run then TSC --help, and it will show you all of the different settings for it. So Webpack and NPM and TypeScript compiler, they all work together to then output, to take your TypeScript code that you've written and then convert it into code which is then suitable to be used as JavaScript, all right? And it spits it out into, at the moment, this bundle. So there's lots and lots of code. You really just don't have to worry yourself about this. Is the whole point why you should learn JavaScript. The whole point why you should learn TypeScript, because you learn one language and you don't have to worry about whether it's compatible for browsers that are 5 years old, 6, 7, 8 years old, whether it's Chrome, whether it's Internet Explorer, whether it's Edge. You don't care. You just write TypeScript and you let the people that are in the background make this code for you, all right? Because that's what I do. I worry myself about programming and not about making everyone happy with how I code. I just make sure my code works and my code's documented and tested, and that's it. So just let these other people that are experts in their own area do this and say, hey, here's a tool, use this tool to transpile your code. Right, so Webpack does this for us, okay, and it will spit out this development code here, where your code will then work, all right? And that's essentially what happens. So if I then say main.ts here, and we use the compiler here, and we say ts, and I say source main.ts, it should spit out. Okay, cannot find YouTube. Okay, that's fine. That's because get rid of this and do it. Whoops, and we'll do it again, just to show you what we have here. And now we can look at the main.js, and then we see it's essentially exactly the same code, but now all of the const have been changed to var, and all of the type definitions have been removed, and so on. So that's essentially what's happening. Now we don't need this main.js in this situation, because I'm using Webpack, which is then going to create this bundle for me, which I can then use in my index.html, right? So it's if you were learning TypeScript or JavaScript 3-4 years ago, 5 years ago, then this would be a completely different topic. But because you don't need to learn it now, you just need to learn TypeScript, and then you can look at the code all the time and see what it spits out. And TypeScript actually has, is it Connect? Has a playground that you can use. Oh, it's there. TypeScript actually has a playground which you can use, which, as you can see here, it will take the code and it will spit out it will transpile, should I say, the JavaScript version of it. And now you can see here you've got class greeter is then var greeter equals function, and so on. So it's a self-calling function here, and then it can be then used as a normal JavaScript object, JavaScript class here, and so on. So this here is clean code. It's testable, it's type, and it's got lots less bugs in it than this here. All right. So and TypeScript actually has a lot more to go for it. So I'm just going to stop for a second because someone's commented, I'm just learning plain scripts. I'm so behind. No, you're not so behind. So if you are learning plain vanilla script, that's great, right? But what you should do is, if you're going to write some code, come to this TypeScript lang. So here we go. Come here, and no, I'm not going to do that. I'm going to place it in the. Can I do it here? Okay. So TypeScript playground. Is that? Should be all right. Okay, so let's just see that actually that's probably there. All right, so this if you go to the playground, so what you should be doing is, if you're learning vanilla script, you should come to this playground and then type in your code here. So if we do the same thing here, David's age, and then we'll do number equals 39, right? And then David's sister's age equals number equals 41, and then diff equals then David's sister's age minus David's age. And now you see what it spits out. It takes away all of the types and everything that's there. You see, so that's essentially what you could do. And now you can see what code you should be writing, right? And this is the code that it will spit out, right? But I don't really want to talk about this. With the latest version of JavaScript, you can use const, and you can use let, and you can use var. Okay, you shouldn't be using var anymore. Okay, you should be using let. Now, let's explain here what let does. All right, and I'm going to do it in this code here. Let's dump this. Okay, and let's actually, that's not what we want here. We want this one here. Okay, let's explain. So explaining let. Okay, so const and let. One is mutable and one is immutable, which means that they've got, so this is immutable. Yeah, 2 M's, I think. Immutable, yeah. So we'll say Wolverine. He's, no. Let's say mutable. Oh, that's Wolverine. And I'm immutable, yeah? So Wolverine can mutate himself, you know? I got it right the first time. So, yeah. I'm not. There we go. That's better. So Wolverine is mutable, right? He can mutate himself, and I'm immutable, which means that I can't change myself. So, but const is completely immutable, which means that you can't change its value, and you can't change its place. Okay, so it has to be a string still. So if we come over here and say immutable equals 39, we'll get an error here saying cannot assign to immutable because it is a constant or a read-only property, right? So once you've written to it, you can't change it again, all right? Now, if we then take a new X-man, is then, it's terrible. Storm. So now if we take Storm here and assign X-men to Storm, to immutable, right? Well, X-men is also a string, and it's the same type here, but you just cannot change that constant, right? Once you've used that equal sign with a value, that's done. You are never changing it again. All right. Now, let's, on the other hand, let's change mutable to this, and we now change this to mutable. As you can see now, we can change everything about changing me, right? We can change everything about mutable. We can change its value. We can change its reference as such by doing X-men, by doing mutable equals X-men. That's changing its reference, all right? And it's also changing its value. So you can do everything with it. So if you know that a value is going to change, then you make it a let. If you know that this value should never change, then make it a const, all right? Now, what's real life examples of this? All right, so let's just save this. Added let's example. Okay, so now that's saved there. So real-time example here is that if a real-time example that people will understand. Well, okay, so without getting too difficult. Right, good. This is fine. So you've got David's birthday is a string, and it equals 22/12/1978. All right, so that's my birthday. You can't change David's birthday, right? It's something that you can't change. Now, if this was let, then you could change my birth dates. Now, when would we, in relation to David's birth date, when would we use let? Well, David's age equals 39, right? In this situation, we can, David's mutable age, yeah? In this situation, you can actually change the value of my age, because as I get older, right, it goes up. So in the code, if the code was then going to be running for years and years and years, you'd want to know that that variable, David's mutable age, can be changed. But David's birthday can never be changed, all right? So that's the difference between let and const. Now, another real-world example is, without confusing you, is we've got x equals a number and it equals 0. X is less than 10. We're going to say x plus plus. Whoops. And this then here is a real life programming example of when let, because let needs to update itself every single time, right? If you don't know what a for loop is, don't worry at all, right? Because we'll go over it later. But this let must be, if we change this to const, you'll see that here it says here, hey, cannot assign to x because it is a constant or a read-only property. This method, or this thing here, this for loop, it needs to be able to change x. All right, so this is another real life example of it. Now, what about if you've got say, like a pendulum swinging left and right? The angle of that pendulum is changing all the time. So you would have angle equals number equals 0, and as the time goes by, it should be say the radius times by, let me get this right, math.sine.angle, something like that, and we'll say that there, the radius, the radius, that is a constant, right? And we'll say radius is then 40, right? So as the time goes by, the angle will change. So there you know that you need let needs to be mutable. I don't want to say a variable. Let is a mutable variable. Okay, constant is an immutable variable. So that's essentially what let does. All right. So I think that was kind of half clear. Yeah. Let's saving this. So let's added real life examples of using let and const. So if you don't know about Git, let's give a quick talk about Git. All right. Now, Git is something which I wish I'd used many years ago to be able to, when I made the video, to send the code to everyone. Now, Git will then save all of the different commits I've made. As you can see here, I said initial commit to testnet fly is deploying, which I did before the video started, introduce constant variables and the numbers, type assignment, and so on. And here you can see the code that I then removed, and I then changed it to be then this, and so on. So it's showing all of the different work that I've been doing. All right. And why is this good for you in the beginning to learn? Because once you've done some code, once you've written a part of your code and you think that's working, and you want to be able to save that state. So if you do then make an error, you can then go back to where you were, right, and not have to like kind of remove code that you think, oh, did I change this? Did I change that? So you can literally instantly go back to the position where you were and let someone else, another expert, deal with how how you're actually going to do it. All right. So I hugely advise you learning how to use Git for version control, because it's absolutely awesome. All right. Now, if you want, there's also continuous integration, continuous deployment, and that can be done at netlify.com. Once you have a GitHub account, you can then publish your websites here for free as well, using Node and so on to build them. Okay, but that's another topic. So this is what GitHub does with version control. And if you want to be able to follow this, then you can then download the repository, okay, right now and see it. So I'm gonna have a quick drink. I'll save the live for watch later. Yeah, it's good. I just thought I'd do this now because, in actual fact, I wanted to watch. Thanks, bro. Keep it up. Yeah, it's no problem. I'm just doing this, to be honest with you, because it's a Friday night and I can't watch the Bundesliga. I'm in Germany, so I thought I'll do this video until the highlights come out on Sky, and then I can watch the game, because Dortmund plays tomorrow. And I had nothing better to do than to do this, so I thought I'd help some people, and hopefully maybe there's some interaction. So come on, please, if you're watching, just write something in the chat to tell me actually who's there. And so far, are there any things which you did or didn't understand? Am I going at the correct speed? Is there anything on the quick start? Is there anything on the documentation which I should go through next? All right. No, don't want that. Quick start. As you always go to it the first time. Tutorials. Handbook. Oh, there we go. Okay. So basic types. We've kind of been through what a let and a constant is. So let's start going through now. Boolean. All right. So Boolean is pretty cool. Now, if you don't know what Boolean means, right, in programming terms, it means yes. Well, yeah. Huh? It means yes or no, on or off. It means 1 or 0. It doesn't mean left or right, but I'm going to use it. Up or down, right? It's a binary answer to say programmer's issues that he can't find an example of define a variable name. Yeah, that's also, it's a true thing. Is that a good programmer will always find a variable name that fits to the value that is going with. So another programmer in a later stage can look at the code and know exactly what that variable is. Now, to prove your point exactly here, to say A equals some completely arbitrary information, right? And later on in the code, the person sees A, and it's like, what is A? You know, what is in there? But if this had here is some completely useless variable here, then you can look at it and go, oh, okay, some completely useless variable that we just don't need to worry about. And so this is another part of programming, is the variable names are so important to another developer and for you at a later stage to understand what it is without having to scroll back 1,000 lines of code or looking everywhere about what it does. So that was a really cool point. Well done. Kind of skipped over that because yeah, I kind of just do it all day, every day. Right, so Boolean. Let's just pop this back up here again. And there we go there. Okay, so Boolean can only hold one one of two possible values, all right? And that essentially is 1 or 0. Now, that means true or false, all right? True is basically just a type definition of integer. An integer is just 1 or 0, okay? So when it's 1, you know that it's true, right? And if it's true, you know that it's 1, right? And if it's 0, you know that it's false. And if it's false, you know that it's 0, okay? But essentially, anything can actually be true, all right? If it has a value set, it can be true. But with a type, you can then check for other things. Don't want to get into it. So we can say is watching, all right? And we can then use the type definition here, and we can say true. Okay, so we can then say, yeah, okay. So now if the person is watching, then it's true. And in a, no, I don't want to go through your statements yet. Is watching is Boolean. So if the person is not watching, then it's false. It can't essentially hold any other value. And if you put 1 here, you'll see it says is watching is declared, but its value is never read. Fine. But 1 is not assignable to type Boolean because 1 is an integer and it's not a Boolean. But let's have a look in here to see what this one says. Watching equals Boolean, and I'm going to say 1, and that's going to moan at me, right? But we can also say this and see whether that then moans at me. Whoops, don't want a big B. Okay, so this one then will say conversion type number to type Boolean may be a mistake because neither type sufficiently overlaps with the other. If this was intentional, convert expression to unknown first, right? So although 1 can be in other programming languages true, TypeScript has done it in such a way that it's only letting you to assign the type on the right hand side to the variable type on the left hand side, right? It's being so strict to remove any bugs that there possibly can be, because the biggest problem that people have in programming is programming bugs. Now, bugs are stuff that you don't notice. Bugs are things that you don't know that you're programming at that time. But in this situation, in this situation, is watching is strongly typed, which means you can only give it true or false. Yeah, so when would you use, well, real life examples of when would you use is watching or use this is right now. If you've got a user, for example, that has their first name, surname, age, and you want to know whether they're watching your video or not, then you give them a property of is watching, and then when they are watching, that you can then set it to false, and when they are watching, you set it to true. Now, if this is then, if it can be mutated, then it needs to be a let variable, or it needs to be a const. So, and in this situation here, is, let's say, is legal. All right, is that can the person watch your video, or can the person enter your shop, or can the person do the thing on the website that you want them to do, right? If we're saying const is legal, this could mean that the user has been logged in, right, and you've checked their age and they're, say, under 18 years old, and there's a specific part of your website that's only for people that are over 18 or 18 or over. So you'd want on their profile that they are is legal, right? And that means that they are the legal age is of, let's say, is of legal age, because you don't know. Okay, let's say for buying alcohol. Now in the UK, buying alcohol is 18. In other countries, buying alcohol is 21 and so on. And in some countries, it's like 16. So is of legal age could be that you would have a Boolean and you'd want it a constant, because depending upon which country they're in, it will only be one value, right? So yeah, that's that. Right, so that this is let's go through. Names. Okay, what else have we got? So we've got number, we've been through. String, we've been through. Full name, we're not going to go through that yet. Sentence, yeah, okay. Array, tuple, enum, no, any. Okay, yeah, any is worth a shot now. So if you don't know the value of something, then what you can do is you can give it the value of any. All right. So if you've got unknown property, and it can be this, for example. Okay. Now it can be that whilst you're programming the code, you want to have a property inside of a class or so on, but you don't know what type it can have at this point in time. So you're not aware of it, but you don't want to leave the code out. So you can give it this type of any. Now any can hold any type. All right. So we can say true here and nothing. It doesn't moan. All right. We can then say 15 and it doesn't moan, etc., etc., etc. Now, real life examples of this would be that you're giving that is kind of real life examples. There is you don't really know what the property is going to be, but the person receiving it can work out what it's going to be, right? And this is it. If you can't put a type on it and you don't know what it is going to be, then put it any and let the other person try and work out what it is. And if it isn't the right type that they want or doesn't have the right properties that they want, then they can just ignore it. So it's a way of saying to the other program or the other code, hey, I've got something, you check what it is because I don't want to. All right, and that's by putting any on it. So, and what do they say here in any? Let's have a look, shall we? We may need to describe the type of variables that we do not know when we are writing an application. Okay, these values may come from dynamic content, e.g. from the user or a third-party library, like I said. In these cases, we want to opt out of type checking and let the values pass through compile time checks. To do so, we label this with the any type. And as you can see, not sure any, not sure maybe a string instead, not sure false. The any type is a powerful way to work with existing JavaScript, allowing you to gradually opt in and opt out of type checking during compilation. See, this is the key part. Which parts of your code must have types on it and you don't want them to break, and which parts of your code are very, very flexible and you don't mind. All right, in that type, if you can put a type on your variable, put a type on it. All right, but if you really don't know and you're not sure, then put any. Okay, so if we have a look here, so not sure any, if it exists. Okay, if it exists, might exist at runtime. Not sure to fixed. Okay, to fixed exists, but the compiler doesn't check. Okay, so pretty sure object equals 4, pretty sure to be fixed. Yeah, the any type is also handy if you know some part of the type, perhaps not all of it. For example, you may have an array, but the array has a mixed different types. Yeah, this is also interesting. Is that we haven't got through to arrays yet, so we're gonna leave it. And void we're also gonna to leave. Okay, so null and undefined. Now they caught. So let's talked about any type. Okay, so let's just read this from null and undefined first of all. Or let's just give a quick background to this. So in the beginning, when JavaScript was created, it was created with two types, which they call it the $2 billion error. Okay, one for $1 billion for null and $1 billion for undefined. Now in JavaScript, things can be null and undefined at the same time, and sometimes things that you think are null can be undefined, and things that are undefined can be null as well. So you're continuously checking if this property is not equal to null and this property is not equal to undefined, then do something. So this was one of the main reasons why they created TypeScript, to remove this problem here. And by removing undefined and also any, they solved, sorry, undefined and null, they removed so many problems. All right, I think it was like about 60% or something of problems just in one go, because it's not possible to have two values anymore. It can only have one value unless you've allowed it to have two values. And there is a way of doing that as well. So why would you have, first of all, why would you have null? This is a question. And how can you have null? Now let's have a look at the documentation for null. Okay, so you've got that n equals null is equal to null. So in TypeScript, both undefined and null actually have their own types, named undefined and null respectively. Much like void, ignore void, they're not extremely useful on their own. Okay. Okay, by default, null and undefined are subtypes of all other types. This means you can assign null and undefined to something like number. However, when using the strict null checks flag, null and undefined are only assignable to void and their respective types. Okay, so undefined are only assignable to void and their respective types. This helps avoid many common errors. In cases where you want to pass in either a string or null or undefined, you can use the union type, this here. Explain later. Once again, more on union types later on. Yeah, as they've said it there. As a note, we encourage the use of this compiler check. And if we come to the compiler check and talk about this now, we have this tsconf.json. And if we search for this here, you can see here, enable strict null checks. So let's just put that on, shall we? And no implicit any. Yeah, that's good. Let's continue on here. Okay, so whoops. Where are we then? When possible, but for the purpose of this handbook, we'll assume it is turned off. Oh, I like to have TypeScript on with absolutely everything on. So you know the compiler is absolutely yelling at you all the time, and you learn how to program and stop the compiler from yelling at you. But you know that your code's a lot safer from doing that. Anyway, so let's go back to here and real-time example of when you would use null. I can't think of a real-time example in this at the moment without going deeper into something else. because okay, we can let's go up here and we'll skip on to you've been introduced with null and undefined, but maybe we've got to kind of creep back into it again somehow. So let's now talk about an array. And TypeScript, like JavaScript, allows you to work with arrays of values. Array types can be written in one of two ways. In the first, you use the type of elements followed by the open and closing square brackets to denote an array of that element type. And as you can see here, there's a list of an array of numbers, and here, and so on. The second one uses a generic array type. I'm not even going to go over this because that's talking about something else now. So let's explain this in the playground. So we've got because okay, so we've got let's call them indexes, all right? And the indexes, whoops, this is the indexes of if you've got, like, say, it's difficult. Okay, so if we're adding up all, yeah, okay, fine. We're doubling always the next number, okay, like so. So now we have an array of numbers. Now we have an array of numbers, all right? And this, what is an array? Well, it's a collection. An array is a collection of something. In this case, we can see the type here is of number, right? Because we've given a list of numbers, and we can access each element here by just saying, if we do this in the browser, actually, it's going to be easier. Do this. And we'll say indexes equals 1, 2, 4, 8, 16, 32. Right, so now we have indexes, and if we then say indexes and say 0, what we're saying here is give me the element at the index of 0. Now, we normally, when we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, we've got something called a 0 index, which means that the first element starts at 0 rather than at 1. So if we've got 10 elements, that will mean it goes from 0 through to 9. If we've got 11 elements, that will go from 0 through to 10, and so on. And you see here that we say the index of 0 is then 0, and then we say the index of, well, we've got 1, 2, 3, 4, 5, 6, 7. So the index of 6 is then 32. The index of 4 is 8, 3, and so on. 2. So this is how you can access the different elements of that array. Now, if I say index of, there we go. That's how we can explain it. So let's go back to this. We get undefined, right? So if we've, yes, exactly, right? If you've got an array and you don't check the array properly. Now, to show you this inside of the code, all right? So let's come here and say undefined array, and we've got indexes here, and this is then of number. One, 4, 8, 16, 32, right? Now, you can check, so if we want then last, and lots of junior programmers will always make the mistake here of not using a 0 index. So 1, 2, 3, 4, 5, 6, 7. And we're like, yeah, but we've got 7 numbers, So give me the 7th index. All right. Now, as you saw here, when I said give me the 7th property, it is undefined. So we know that this number here is undefined. All right. It's not going to be a number. It's going to be an undefined. And now, from what I'm on the understanding, is we can say we can do this as well. So now, last is okay. Now we can say that last is a number or undefined, because it might be that some moron who wrote the code before us didn't bother to check whether that index actually existed. Now, you could fix this by, what do you want to do this? If the length is okay, then if length is less than or equal to 7, then you get this, yeah. Otherwise, you get undefined. All right. So what we're doing here is we're checking that this place is actually in there. All right. And we're saying, hey, index is length, which is then going to go along and going to count them. So it's going to say, hey, I've got seven items here, and as long as we know that we've got 7 items, well, this is still going to have a problem right now. So if we copy this code, right, and put this in here, yeah, and see what it says. It says undefined, right, because we're still asking for 7. So if it's less than equal to 7, this is then, less than equal to 7, then we've got to know that it's 7 minus 1, all right? So you've got to go to the 0 index. This is what I'm trying to slowly get through to you, is that you can check that there's a 7th item there, but once you go and access it, you've got to knock that 7 down to 0 index, all right, to put 0 back into the equation, all right? So this is fine. So if you're going to do something like that, check that that something is undefined, because you never quite know what this can be. So there's an example of where undefined can be used, all right? So, and now here, you could say if last is not equal to undefined, all right, then do something here, right? So if last, we was basically saying if last is a number, then you can do something here, all right? Let's undefined using raise. Okay, so now if we want to add an item, let's go to the playground and do this. If we want to add an item to our indexes, we've got to then say we can then say push, and we'll say 64. Whoops. Push 64. And so now when we do is 8. So now we know that anyway, that's not the point here. So we can. How do we remove elements from an index as well? We can say pop as well. Which then, if we look at how many things are in the index, we can then see that the last item is then removed from the list. So every time you call pop, it's going to remove the last item of the list. And if we do it again, we get to 0, and now we should get undefined again, right? So there's another situation where undefined comes up. But in this situation, you should be checking if indexes is more than 0, or indexes dot length is more than 0. So pop. So we can say last item equals indexes dot pop. All right. Now this too can be number or undefined. Okay, because pop, and it says here it can return a number or undefined. Okay, so you always need to make sure that you define your property with the correct type. Now, I don't know quite how long this video has been going. It's like an hour, but I say to our apprentices at work that the primitive types are the most key part of programming, because once you've learned all of the other if statements, for loops, and so on, how to write classes and methods, you've learnt that. But then it's about the controlling of data and that you don't make any bugs. And you've got to make sure that you add the correct type for everything, and you've done all the correct checks for certain things. So if you're using this indexes and you want to access one of these elements, you've got to make sure all the time is, so first, does that element index exist? If it does exist, then retrieve it. If it does not exist, then handle the error. You know, so but if you just go straight for it and say indexes at the index of 8 and you haven't checked, this could be where your code crashes, where it causes a problem. You know, this is essentially hard coding a bug directly into your code immediately whilst you're programming it, where you could just add another couple of lines of code and it can fix it completely. So we've kind of been through, and we've kind of gone on this just for a second about if statements. So in this situation, if last item is equal to defined, we've got this other property that we can use, right? Which is called error. All right. Now, it's not a primitive type, but it's a way of making your code explode if there's a problem. And now, if this was okay, this index is .pop. You're kind of waiting for it, but essentially here you should. Yeah, the code somehow should already end if yeah, I mean, the problem is there isn't a good enough example here to show you this. But let's just say that this indexes is a never-ending list of numbers, all right, and it will never be empty. So we're just going to say if last item is equal to undefined, we're going to skip over this new word. We're going to say throw, and we're going to skip over this throw word as well. Throw new error, right? And yeah, and we can then say, yeah, the last item is undefined. This can't happen. And essentially, your code's going to break from here. Your code is just going to break from here, and you'll see an error in the console. And if we say here, throw new error, your code has broken. You see, it will tell you that your code is broken and that an error has occurred, and it comes up here as well that an error has occurred. So but we'll skip over that. That's just essentially how you handle a problem at one time. Okay, but so to give you another introduction into this is, let's say item equals number and undefined. Okay, and then we'll say indexes pop, and we'll comment this out here. So we have our indexes here, and now we've defined an item which is going to have a number or undefined, and we're taking the last one off the list already. And while item is not equal to undefined. So now we're doing the opposite, and we're going to say do this code whilst item is not undefined. And what's going to happen? Okay, run this code when item is undefined. Yeah. So this is, and then we're going to say here is do some code here, and then we say item equals indexes dot pop, and this will run. Okay, so let's go through this. It will pop. This is 32 first of all right, and then it will say if item is not equals undefined, so but it's not undefined because it's a number. Do this code here, and then pop again. All right, and item has then been updated with 16, so it starts here again, and it says if item is not equal to undefined. Well, it's not because it's 16. Do the code here, and we pop again. Now we're 8, code, pop again, 4, code, item is then number 2, once again, number 1, once again, and then 0, once again. And this time, so this time we do the code because it's 0. Okay, item. Let's just say it came here to 0. So indexes only had 0 in it, and it said pop, and item has a value now. All right. So item is not equal to undefined. That's correct. It does the code for 0, and then it pops again. Item is now undefined. So it's going to skip out this, and it's going to come here. So it's done the code for all of our indexes. All right. And now indexes is empty. So that's how you could use undefined. There are other ways and means of doing this as well, but that's just an example of how you would do it. So let's add this and say if git commit demonstrated using a while loop to iterate through all indexes until the item variable was undefined. Okay, so that's pretty cool. All right, it's now null is also something. If you know that you're not going to be if something's not going to be undefined, but you could you could also then say, okay, let's explain null, shall we? You could use undefined for this as well, but let's explain null. So let's say that we've got yeah, okay, okay, you're going to have to completely ignore this. All right, we're going to go through this later. So we'll put this up here, and we're going to say here is connected. All right, and this is going to be Boolean or null, and in the beginning it's true. Okay, so this is saying, this is a pretty good example. This is saying if we have a connection to a database or a connection to a server, connection to the internet, a connection, right? Then inside of our code, we're going to say if is connected, then continue if is connected. Okay, and we can do shorthand code, which we'll go over later. We'll say return. So this is just going to essentially just exit completely out of here, and it's not going to have. So it has to be is connected has to be true to go on. All right, and if it is null, this will also be false. Okay, and we can test this in here. So let's give is connected is null. So if we say it's undefined, yeah. So if is connected console.log, well, it's not, and we'll say, and we'll come back to this again, and we'll say is connected. Do you see what I mean? So we're using a variable to be null, and if it is null, then it's going to be false anyway. All right. So we're in our loop, and this then takes an item. All right, we're just going to call it x. X I've never used, so we're just going to say x. All right, and that's going to output x. Okay, and we're going to give this a type of number to be happy. All right, and then we're going to say asynchronous callback is item, and this has got to be right. So this has got to be okay. In this situation, we're then going to say, yeah. Yeah, we're just going to, no, I'm not going to do that. So if no, I'm trying to keep this nice and simple for you. Say result. If item is equal to undefined, equal to undefined, and we're going to say 0 else item as number. And say result. Okay, so asynchronous callback. So this means that something is going to happen asynchronously, right? Which is another phrase that we shouldn't be using. And it's going to call this here. And if is connected, it's going to continue on and do this. Now, it can be that somewhere inside of our code here, that it then suddenly says is connected equals null, right? So now we could use false here, but it's going to mean that it's going to come here and it's going to go inside of our asynchronous call, and it's going to say, hey, I don't have a connection anymore, so I need to, I can't do it. I'm just going to ignore whatever's going to happen in front of it. So it's a way that you can use. It can be that, you see, by having by having null, it means that there's no connection whatsoever. Now, is connected, if it's true, it means there is a connection, right? And if false, if false, then it can mean I've got to activate the connection. You see what I mean? But if null means, hey, there's no connection whatsoever. You know, you've got no LAN cable, you're on airplane mode or something, there's no connection. But if it's not connected, that means activate your connection. But if it is connected, do the work already. So this is how I'm saying that you've got Boolean in this situation with a third meaning where it's not even a Boolean anymore, and you can check for that. So there's this is not really like beginner stuff, but I'm trying to give you a real life example of where I would use that, and I use this scenario all the time to use Firebase, okay? Because Firebase will do something when I'm programming iPhone apps. You press a button and it will go off and do a call to Firebase, and I only want it to do it one time, and sometimes it does it like multiple times, but I only want it the first time. So once I've been inside of this method, it can be that the next line of code takes a little bit longer until it's finished. So I then will then say is connected is null, so it doesn't come here again. And it's just a handy way of using a variable with more than two values that can be stored in it. And Boolean is, so it's, you don't have to read between the lines there about what I'm saying. But that's kind of, I'm kind of opening doors here now, because we've seen if statement, while statements, undefined, null, and also lambda functions as well, and callbacks. So I'm kind of opening the doors up here for more and more things. All right, so let's save this. That is example of using a callback and null to circumvent an event. Available. Right. Well, I'm gonna, if no one else comments on here in the next 2 minutes, I'm gonna stop this one. I'm gonna have a little bit of a break, and then I'll continue in another one. I don't even know where it is now. Right here. Where is it? Oh. This is chat. Have we used this before? Oh, yeah. Well, this says 2 users viewing, and I've just switched off this one. I'm guessing this doesn't watch, so it must mean that someone's watching, at least. Anyway, right, well, I'm going to take a quick break. So it's, I'll keep this running. Let's have a look in here. I guess you had a series on Ionic framework. Guess you had a series on Ionic framework. No, I haven't had a series on Ionic framework. But I've worked on. Oops. I've worked with. I didn't want that one. I want this. I've worked with Ionic framework. I've also worked with Nativescript a lot. I've worked with React Native. I've worked with what were some of the other ones? Flutter. Flutter I like. But yeah, Ionic, I'd rather use Nativescript if I'm going to use a framework like that for building apps. Is there any questions about what I've done so far, or are there any questions that are questions? Please, come on. So it's 6 minutes past 11 at the moment. I'm going to do 4 minutes of the microphone off, and then take a break for myself because I need a break. And I'm back in 4 minutes. Okay. Not quite sure about that chat bit there. Just view YouTube. No. What else can I actually do here? Apart from nothing, which it seems. Control room. Yeah, that does nothing. Let's present to everyone do. Anyway. Good, then if everyone can hear me, then I'll continue on. It says here there's 2 people watching, or 1 person. But anyway, well, I'm going to take a rest. If no one's going to make a comment and so on, then I'll take a rest, have a think about a couple more examples that I can do. And yeah, maybe then start okay, I feel like it's a bit bad by showing this function without actually giving some background information to it. Or we can all right, good, then we'll continue with functions. Okay, let's see what our friends at Typescript have got to say about this first. So functions, let's have a read through this, shall we, because it's kind of interesting. So functions are the fundamental building blocks. I'm going to say it again. Functions are the fundamental building block of any applications in JavaScript and in any other programming language. Right? They're how you build up layers of abstraction, mimicking classes, information, hiding, and modules. In TypeScript, while there are classes, namespaces, and modules, functions still play the key role in describing how to do things. Couldn't agree more. TypeScript also holds some new capabilities to the standard JavaScript functions to make them easier to work with. So looking at here, we've got, to begin, just as in JavaScript, TypeScript functions can be created both as named function or as an anonymous function. This allows you to choose the most appropriate approach for your application, whether you're building a list of functions in an API or a one-off function to hand off to another function. Okay, to recap, so let's have a look at this, right? So what the documentation is saying is that we've got add, which is then x number, y number, and it's then going to give a number back. And we're going to turn and say y plus blah, 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 and it's going to do it there, right? And if we then do this, we can then add the x and y together and returns the result. Right, a good programmer always documentates its code as well, all right? So this is now a function. This is a global function which can be used everywhere, all right? Now, what we could also do is say add numbers equals this here, right? And this is another type of it, all right? And to confuse matters even further, I'm skipping by what they wrote. Whoops. And then we're going to copy this again, put it in there, and then go this. See, it recognizes exactly the same thing. Oops. Does the same thing. So now you see we've got two functions here that do exactly the same, but if we highlight over it, it still says the same thing. But this one says it's a local function, and this one says that it's a constant, right? And that it holds a function. So what about the next example? Is then add number function equals function. Here we can return. I haven't written function in a long time, and we're going to copy this as well. Just can't be bothered. Copy this as well and return this, and then tap on here and do this, and do this. Now look on here. This says this is now a const add num function. So this one's an actual function. You see, it gets this local function, and this one, and they're all exactly the same. Okay. Where is the difference here? Well, this is like a legacy. This is like a legacy one. Okay. This is like the new version after that, which is anonymous functions, but they're essentially, what do they call? Okay, so here's a named function where you say function this here. Anonymous function is you kind of give it a constant, all right, that it can change. And my one is called a lambda. Okay, this one here is called a lambda, which I'm going to nicely skip over. But they're all exactly the same things. Now, they're not type hinted either. So now what we can come here and do is we can take this, we can type hint them as well. We can type hint that one. And this one can also is this also, and we can copy this. Oh dear, why is it doing that? Okay, so now you can see that we're getting a lot more information about it, and it's distinguishable. You know, you're looking at it and you know exactly what it does, which is better. So this is why I like TypeScript. Now, if we were just doing this in JavaScript, this would just be like func equals func, and we'll do return x plus y, right? And we'll just do xy here, yeah? And this would be fine in JavaScript, in normal vanilla JavaScript. This would be fine, you see, because we don't have to have any type information. We don't have to have any return value. It can just be anything you want, right? So you could pass 15 arguments to this one function, and it'd allow it, right? You could pass a string to the first one, an array to the second one, and then do whatever, and it would allow it. It would be fine. But with our ones using TypeScript, it won't allow it, all right? It won't even transpile. That's the whole point behind it, all right? So the next question is, what does a function do? Right, what does a function do? Right, a function takes an input and gives an output. Right, so it's as simple as that. So it takes an input and provides an output. Now, it can be, you know, it can output anything. Right, it can output a number, a string, an array, an object, a class, anything that you want, it can return. Now it can also return void, meaning it doesn't return anything, right? Now essentially, all methods have to return something, but if you're not returning any value, you can return void. And there are some other things that TypeScript allows you to do, but we're not going to get into it. So let's have a look at our add function. How would we use our add function? Well, if we go back to the beginning, we have sum. We would then say add, and we've got add 5 and 2. And now we see sum cannot, we'll say added sum. But now we can see added sum is a number right from this. And we can then say added sum 1 equals added numbers. And once again, we can say 5, 6. And we can say added sum function equals added num function 7, 4, and so on. So they all do exactly the same thing, right? But they all return a value. So this function takes 2 inputs and gives 1 input in return. This one takes 2 inputs, gives 1 output. Okay, and functions basically only ever give 1 output. They only give 1 output. Now in this case, it takes an argument of an X and a Y, and they're both of type number. Okay, and it returns a type number. Now if we then said any here, we can see what the compiler says, transpiler, and it's saying that's fine because number plus number equals a number, and that is a type of any anyway, so it would be fine. And we look at add numbers. Now gives us a number back, right? Because that then says that there, which we don't want. So now we see now we get type any back, which is that changes from back. Okay, so let's save this because I've got another interesting thing to show you with functions. So let's save this. Created the basic ways you can write functions. Okay. Now, if you're watching this another day, right? This is where JavaScript gets interesting now, all right? And this is where I believe you're going to be thankful that you're watching this, because we're going to step it up now a few notches, all right? Okay, so now in TypeScript we've got types. So let's say type is add number function, yeah? And this is going to equal, am I getting this correct is the question. Okay. Yeah. Is that doing it? Oh, okay. I didn't like that. Didn't like that. Okay, so now we're saying that add number function is we've defined it right as something. So let's write our, let's call it high order function equals function, and it's going to give any. What am I doing, David? Okay. So now it's our function that doesn't take any parameters, and it's going to give any in return. So we're just going to say true. Okay. Now, what is a high order function? And the people that are watching, or the person that's watching, right? Please tell me you do or you don't know what a high order function is. Because if you don't, then pin your ears back and listen now, because there's not many people as beginners that know on day one or week one what a high order function is, right? And this is going to help you. And pin these words into your head. High order function, right? This is going to save you in the future when things get complicated, right? High order function. Okay, so now what we're going to call this is we're going to say this is a callback, all right? And we're going to say this here is a callback, and it's an add number function, okay? Now, so what we're going to do is we're going to take parameter X and a parameter Y, and we're going to go, I have no idea what you want me to do with this X and Y, right? But I tell you what, I'll let you decide. I want to know when you're going to do it, but I'll let you decide what you're going to do with it, right? And I can come here and then can say X and Y, and I'll return the result of number, all right? So you see here, so I could then calculate something here, oops, and you can do the math because I don't like it. All right. So, what other scenario can we do this? Oh, I did it once. That's why. So, okay, takes an X and a Y and passes it to the high order callback provided and returns a number. Now, when would you want to use something like this? Well, let's have a think about this. Oh dear. Let's have a think about this. So you've got map okay, we've got types, okay? Okay, person name we're going to call it, right? And person name, we're going to skip over types, like here. Person name is then a name. We call it first name, last name, okay? Yes. We're going to define, no, we're not going to define, we're going to write this one. So map full name to person name, all right? And this is going to okay, so this is going to give back oops. So what's happening here is that it's a function that we're going to call, so map here, and this is then okay, so now we have full name, we have first and last name, okay? So no, this is then person's name, okay? So, which means this method needs to take a full name in, right? And we're going to say here, David Thorne. Okay, and that is then going to map it to a person's name object. And what we're going to do in here, we're going to call parts, and I'm going to say full name, or is it split? Yes, it is split. By space, and I'm going to say parts, and then, parts is then shift. Shift does what, David? Removes the first element from an array and returns it, right? So let's also say that this can return null, all right? Okay, so now we need to work out how we can solve this without any problems. So we'll just do undefined is better. So if first equals parts dot shift. Oh no, this is fine. Okay. So if parts dot length is less than 2, we're going to return undefined. Okay, because we want to know that this has been split down into two parts. All right. And if it isn't less than 2, we're just going to say if it's not equal to 2, all right, then go away. We don't care. So we want to know that we can call, yeah. Okay. So now we know that it's equal to 2, so we can shift it, and yeah, it's fine. So now we can first name, last name. All right. Okay. So now it's this, and we could actually do this now. Is equal to undefined throw new error. The name does not have the correct number. The name does not have not correct number of parts. Okay, see how now is TypeScript is clever enough to know that you've checked that person name is not undefined. Okay, now if we get rid of this, comment this out, you see, bang, it has a problem because it knows it's handled already that this person now, if we come here and say person name and look at the type of this, you see it's person now, a person name now, because we've proven that it can't be undefined. If it's undefined, it comes here. Now we've removed this undefined part of it. You see what I mean? Okay, now it means that we can use it properly. So TypeScript is very, very clever for doing this, and that's why I encourage you all day long to use TypeScript because it eradicates any problem that you might have had previously. Okay, so let's save save this. Demonstrated how to use the map function. Demonstrated how to use demonstrated how to use high order functions. Okay, so just to reiterate this. So what we've defined here is a map full name to person. So we've tested our map full name to person name function, right? And we know that it's all working properly. So now we can try our now we can build okay, so map person, so I'm just going to define it first, and this is then going to give person name in return, and it's then going to say the name, and I don't want to handle this, and we're just going to call it map. And we're going to say that this map needs to take this and it needs to take name and give a string. Okay, so now we know that what our here to make it properly typed. Do this as well. What am I doing wrong here? Okay, good. So now we've got here. This is the type definition, and this is the actual function that we're implementing. So now we just say, all we've got to do is call this map function. This map function takes the full name and it returns it, you see? So we're saying, well, wait a minute, we just want to take a name, a full name, and we want someone else to split it because we're not interested in the rule. Does the person have 3 names? Like my name's David James Thorne, you know? So if I enter my full name, then it would throw an error here. It would throw an error here because it's undefined, you know what I mean? And it would throw an error here and so on. So that's why this function here is not interested in the implementation. It's just interested in the usage, okay? So now when I say name equals, I can say David name, and I can use it, and I can say David James Thorne, see? And my map function is I can just say here, map function, and that's it. Argument of full name, blah, 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 it's not assigned. Okay, yeah, that's. And if we're going to change this, we have to change this as well. Type undefined. What? Oh shit. Okay, seems a little bit confusing maybe, but full name, map, person name, and it's not assignable to full name, map. Ah, okay. Up there. Now it's working. Okay, I'm going to get rid of the type definition just for the sake of clarity. And we're going to let the this take care of it. All right. So, and here takes a full name and returns a person's name type or undefined based upon the map function's results. Okay, so that's how you can this here map full name to person is a defined variable before, but it's also a function, a method function which can be passed around. Okay, and this implementation gets passed around with it. And this is the magic of high order functions. And once you start to learn high order functions, it changes how you program. And yeah, it just changes how you program completely, because you can, there's another thing which we need to talk about is closure, all right? And that's going to be in a later topic. And I don't think it's going to be in this video as such, because it's a little bit more advanced. It's not TypeScript for absolute beginners. That's like TypeScript for people who are not beginners anymore, but they're still, yeah. Anyway, let's save this. So now created example of map function using a high order function. Oh dear. Yeah, it's all good. Yeah, I'm quite happy with where we're going at the moment. I mean, slowly but surely. Let's run this code. Tell me how this gets, shall we? Okay, good. Here we go. So we've got undefined at 141. Look, yeah, that's why. There we go. Now that's giving the correct David Thorne back. And if you go down the bottom, you'll notice that if we do the test here, we'll do the same test again. name, and let's start doing backticks now. Go through that in a second. The name, and then let's get in brackets. Oops. From here we can do string interpolation of name. It's actually not a string because it's an object. Right. Let's build it again. Boom! See, the name undefined does not have the correct name parts. So that's because it has three parts. So how could we modify this? So let's just small bracket in code. Okay. So now let's see how we could fix this method here to know that, to tell our method how many parts it's allowed to have. Yeah, the minimum amount of parts it needs to have. So that would be somewhere in here in our map function, okay? And that gives a person's name in return. So first of all, we need to know here min length. We're going to call this a number, but we're going to say it's 2, all right? So first name min maybe it's allowed number of spaces in surname. Yes. So then allowed number of spaces. So if part is not equal to that, right? So we're saying, sorry. So we're saying that there's no allowed number of spaces in surname, all right? So that means it's going to return undefined here. Now, that means that the remaining part of the surname is not parts.shift anymore. Or it's going to be interesting. That's parts in parts join. Yes, joins. What does it say here? A string used to separate one element of array from the next. In the resulting string, if omitted, the array element are separated with comma. So let's try this. Let's do here. David, James, Dawn, and then we've got 3. Let's join it with a space. Oops. Okay, good. There we go. So that's what we needed. Okay, and then string undefined. Yeah, good. So now we know that this should work, right? Which means that our methods down here have to take this in as well, all right? And and this is then so now allowed number of spaces in there is we're saying that there's one, all right? Yeah. So let's run and build that. And let's check that my code at my code should now output David Dawn under the bottom as well. Yeah, see, now it outputs everything I want. The last name is now James Thorne, which is correct. But in actual fact, it's not correct because my surname is Thorne, not James Thorne. But in this situation, we've helped it, all right? So we've managed to update that our code works that little bit better, and that we've handled it. So now if we David Jones, Stephen Thorne. Now you have to rebuild it again. You've actually got watch on here as well, but you see, it does not have the correct number of parts. And if we then update this by 2, and then rebuild this again, it works again. All right. So that's that fixed. Updated that function to handle multiple names in surname. Okie dokie. So now we've done that. What are we missing? Let's talk through this type thing now, right? Because it's kind of interesting. Now, there's this keyword called type. And this type allows you to define a, let's just call it an object, right? And slowly, in a minute, you're going to get to an object. You see, you've got this thing called JSON, right? Which is JavaScript object notation. Right? JavaScript object notation. Which, if you don't know what this is, then you need to learn it. Is a way of sending data over the web in such a notation that it can be passed back into the language on the other end. So if we send it in JSON string, and then it can go to, say, a C# application, or it can go to a C application, PHP application, Swift application, Java application, and then be passed into its own language to understand it. So it's there's a confirmation about how an object is then passed, encoded into JSON object notation, okay, and then decoded or passed back into object notation, should we call it, a JavaScript object, or C# class, or a Swift object, and so on, right? So it means that we've got objects in JavaScript, okay, which are defined with open and close curly braces, and the properties in here are name, surname, string, okay, but this needs to have a value, okay. You can't just, it would seem right, you know, just get it out of the way and let the compiler tell you what's wrong, okay. So it would seem right that you're defining, you know, types and values and everything like that, but that's not the point here, okay, because it's just an object. it's a JavaScript object, and it's not a TypeScript object, right? So this is a vanilla JavaScript object, and that's what you've got to remember. Now, if we have a function to take a JSON or a JavaScript JS object, okay, so we got object equals any. And in here, we can say if object, you can, whoops, name is not is equal to undefined, then throw new. This is the way it used to get done. Name is not defined, and then we come here and then we say surname is not defined. Okay, so this is how we used to do it. And then at least here you can now say name equals now you can access it directly like this. So the point is we want to get rid of this code, right? We don't want to write that because we've got any. Now, if you're making a request to, let's come to Google and JavaScript API. No, it's not what I want. This one. Okay, users. So this is what's being sent over the web. Okay, this is just text. This is JavaScript object notation here. This is what's being sent over the web. So in this object here, this address, we'll look at this geo object, okay? It's got a latch name and it's got a value here, all right? Now, we need to know that our property, for example, okay, we need to know that it's got a name and, okay, we'll do name and username, all right? Do name and username. And this is going to go here. So that's this. Okay, so this is the data. This is the data what we're expecting. Okay, we need name and username from this one object that has been sent to us. And let's say that this whole blue highlighted area has been injected or passed into as object. All right. Now we're checking if object property name is not equal to undefined, and if object not we want username is not equal to undefined. Okay, this is what we would have to check. Change this. And so on. This is what we would have to check, and this is what we're expecting to receive. Back, all right, and even the person calling this doesn't know what they're expecting to receive back, because we're going to map it to name equals name, username equals, and anyone's screenshot. You don't have to do that. I know. I'm doing it because it's another thing to explain. So the people who are screaming and shouting, you could do something else here. I know. Right. Keep going. I want a way of saying, hey, this object must have a name, and this object must have a username, but I don't want to have a class sent. I just want it to have a definition, right? And the way we can do this is with a type. So rather than saying let object here, what we're going to do, because this is actually the data which is coming from a network, all right? And so what we can do is we can define a type that goes here, and this type is going to be called user data, all right? And we're going to use an equal sign and then the object notation. So what we're doing is we're assigning the keys and the types to go with it. So we're saying it's got to have a name, and that's got to be a string. It's got to have a username, and that's got to be a string. So anything that's passed here has got to have these two fields, all right? And we can then send this to here, and we can send it to here. So yeah, now we know that anything passed to this being called, we say function to take this, and we pass in name equals David and surname equals Thorn. See what the compiler says now. Look, it says argument of type name surname is not assignable to parameter of type user data. Object literal may only specify known properties, and surname does not exist in type user data, right? Which is true. So it's saying, hey, it doesn't exist. It needs to have a username. So we can't even put that there. But when we change it to username, the transpiler is now happy, okay, which is good. So we now know that we've got type safety on this method parameter, and which means that we can just dump that code completely, and we can say here, a little bit redundant, but we can say here, and we can just return it, see, with no problem. And this is the magic of it. This is now called a pure function, right? Because you're passing data in and you're returning the data in return. Okay, and what we've done with types, we've managed to make a function that does everything for us with type safety, and we can test it, right? We can test it as well. So it's which is yes, it's worthwhile. And if you've written vanilla JavaScript before, which is what we just had previously, let's undo this. Let's copy this, all right? And let's say vanilla function. And then we'll call vanilla function. See, now we just don't know. We just don't know what we're getting back. We have no idea what's in this data. So we've passed something in and we have no idea what we're retrieving. But in this one, so we'll say type save data. In this one, we know 100% what's inside of that object, 100% that it's been checked already, and the transpiler has made damn certain of it. Now, let's just be safe here. We're assuming that the transpiler will solve this at transpile time, which is correct, but it will not solve it at runtime. Okay, so problem here is that you still kind of need to validate this if this data is coming from JSON, right? JSON data, because you've got to validate it. So you've got to have some way of validating this. Now, in my opinion, the best way to solve this is if you then come here and say undefined, all right? And when you return it, it's undefined. So we've got type safe data now, which is user or undefined. So before we use it, we can say user if type safe data I'm always working on an Apple keyboard, and now I'm having to work on a normal one, so that's why it's messing me up a little bit. Okay, the type safe data was not type safe, which can happen because it can mean that someone else's code didn't send the correct code. But now we can now we can see here that type safe data is now type safe, okay, because we've checked that it's not undefined. And if there is a problem in here, then we can check it. And here we can check this as well, because we don't totally know that if we say this is any, right, which is what it will be, right, we can't say that it's user data there, because if it's coming from an API, we have no idea that it's going to be, all right? But so in essence, we've got to have user API user data, right? So in here, what we're gonna start with this now. I'm just going to introduce it. We're going to put question marks on both of these, all right? And we're going to say API user data is going to come here. Now, okay, see the transpiler is once again, there's something going wrong here. So let's get rid of this and let's have a look at what we got here. So it says that the name string or name is either a string or undefined. Okay, fine. So we can now check here. Equal to. So we can now check here if object name is equal to undefined. We can just return. Yep, and then here. Here. Once again, okay. So now. Okay. Now we've used the this is the magic once again. We've used the transpiler to make sure that the code that was transpiled does all these checks for us. Now, if we copy this into the playground, get rid of this, copy this, I'm going to get our two types as well. Now we've got our two types. So the string is not assignable to user data. Okay, it's kind of moaning about that, but let's try and fix this because that's been kind of helpful. We're just going to undefined there. So that cleared it up. So let's okay, so now we can have a look at our vanilla JavaScript. And let's copy it over here to see what it would have done. Okay, so here you can see that the transpiler, it protected our code from doing this. Okay, so we know that when this is passed in, it's going to return undefined all the time. So that code was protected from it. So this is a way that you can do it. Okay, so now we kind of need to explain this. Let's save this code. Demonstrated how to protect API response data. Yes. Something like that. Okay, so now let's explain this optional value. Let's see whether we can find it on here. Advanced types maybe. Okay, so it's here, optional parameters and properties. Okay. I'll explain this. Let's see whether we can. Sometimes it's not very well documented. Union types. Yeah. Type guards and yeah, seen that. User type. Yeah, we've seen that. Type guards. Yeah, we've seen that. That's if the if statement is type guarding. Yeah. This is type guards. Okay. None of the types. Okay, so optional types. Yeah, there we go. That's what I wanted. Okay, so we've got. So now we've got name. Okay, and we noticed that we had David. Okay. Okay, so now we've got optional middle name. Okay, and my middle name is James. Okay. Now some people don't have a middle name, so there's got to be a way that we can make this optional. All right, and where we can say that this is string or null. Okay, and if we, which means that this can take James or null, and if we use if we use this, we'll then see that name is declared but its value is never used. It's actually got a value. This see what this one says now. Okay, this is now null. But if we don't know what the value is, all right? If we write the optional name from any, and then can you do that? Just return null. I'll just return null from that. Oops. Okay, now we've got here is either a string or null. And if I'm correct in saying this is then okay, can only be used in property types. Okay. Oh, this is crazy. Yeah, okay. So you can, we're going to have to go back to this nullable type equals name. All right. Let's say that this returns a nullable type. Okay, so now name at the moment has to have a value, okay? But if we then say question mark, now here, if we say p name equals m name, you'll see that it's string or undefined now. So we've basically said, hey, you ain't going to have a name, right? It can be that it doesn't have a name. So when we build the full name up, for example, so it would be David, yeah, and then on here, right? And in between there's a space. Now in here we could essentially have the middle name, right? And if we use string interpolation, do this. That's stupid on this keyboard. Here, right? So we've got name, and no, we've got p name, okay? But our p name, it's either going to be a string or it's going to be nothing at all. Now, our full name is going to sit together, David space and then surname, because we know we've already tested that the person's got a first and last name. But do they have a middle name? And if they do have a middle name, it needs to sit here, and there needs to be a space before the T, which means there needs to be a space there. But if there isn't a middle name, there doesn't want to be a space there, and this needs to have no value. So we need to find a way of converting this value here, which could be undefined, into a string, okay, without doing if, else, and whatever's, right? And there's two ways of doing it. There's a way of doing it by doing double pipe, and then you give them the optional value. So it's like the default value. So what this is saying is that if property of name, which is optional, does have a value, then give its value. If it doesn't have a value, then give its optional value. So that's what is happening here. So it means that pname always has a string value. And now, if it does have a value, right? Then this is a little bit redundant as well, because we actually have to write more. So here, if we write if is undefined equal to undefined, then do this, else do this, right? Because do this, okay? Now, if you look here, you'll see that we know that mname has been cleaned up. So if mname is equal to undefined, then return a no space, and if it does have a value, then return the name with a space, because we've got to manipulate this name property. So that's why we can't use the double pipe. But if we could use the double pipe, then we would have just then said like we did here, all right? So m name double pipe this here. If we didn't have to put that space in, then that's the way that we would have done it. But because we've got to add this space in, we need to do that, yeah. Because we need to access it. But maybe you could. Anyway, yeah, maybe you could actually around that. You could equals mname dot name dot contacts, I think. Contact. Seems to be attended to the end of the string. Return. That would then give it a value. No, that's not good. This here in this situation resolves that perfectly, right? Because it's still one line of code and it's still clear what it is that you're doing. And we've talked about string interpolation here as well, which is all good fun. Well, I think that's enough for me for today. It's nearly 3 hours, and I think we've gone through a great deal, to be honest with you. And if you have watched all of it, then well done to you. I mean, if you're watching this at a later stage after it's been recorded, then you know, then I hope it's good. If there's any points that need to be split up, talked about more, then let me know. Okay, let's just save this. Explain optional types and how to guard for them. Anyway, so as we all know, the data is all here, a whole bunch of commits that's there. You can see just then the stuff that we've just done. So if you have any questions, anything like that, then don't hesitate to ask. Yeah. I'll probably do another video tomorrow. So yeah, it's all good learning. And you know, have I learned anything today? Well, probably not. But it's made me think a little bit more about how to do some things a little bit differently. But okay, so it's just after midnight here. So I hope, yeah, thank you very much for watching. That's it. So please like it, comment, subscribe, dislike it if you disliked it. But if you disliked it, then write a comment, tell me why. You know, I'm not against negative feedback. Negative feedback's better than no feedback. So anyway, that's it. I'm knocking it on the head here. Good night.